Hello, we're on Unit 1, Day 2 notes. Again, we're going to talk about graphing and analyzing functions. This is kind of a second day of what we did yesterday. So just to remember a few things, remember that the x-intercepts are the same as roots, which are the same as zeros, which are the same as solutions. And that can get a little bit confusing, so let's write this down. And I'm going to highlight those key words here. So let's go ahead and write down that x-intercepts. I'm going to put equal roots, which also equal zeros, and they also equal solutions. And if you can remember, all of those things are just talking about the spot where the graph crosses the x-axis. Okay, so go ahead and get that in and make sure you understand that those all mean the same thing. Okay, example 1. How many real solutions does the graph have? Real solutions. Those are just x-intercepts. If we're looking for x-intercepts, we're just looking for spots where they cross the x-axis. So I went ahead and put 3 blue dots in there where my graph, my red curve, is crossing the x. If I count those up, I have 3, and that's what we're going to call 3 real solutions. Or 3 x-intercepts, or 3 roots. Problem B, look at your red line here. How many times does it cross the x-axis? Well, it only crosses once, so I'm going to say I have 1 real solution. Or I could say I have 1 real root, 1 real zero, something like that. My next one, I have this blue curved line going on, and I see that only in 2 spots does it cross the x-axis. It goes up and down a lot, but it only crosses the x in these 2 spots. So I'm going to go ahead and write that I have 2 real solutions. Okay, you could say you have 2 real x-intercepts. You could say you have 2 real roots. Those are all the same thing. Okay, when dealing with a polynomial, the highest exponent is how many solutions the polynomial will have. And kind of let's just write an example and see if you understand it this way. If I gave you an example and I said y is equal to 2x squared plus 3x minus 5. And I said, okay, just from this, I know how many solutions we have. Okay, not even looking at the graph, just looking at this function that I gave you, I know how many solutions. And the way that I can tell is my little exponent there that I have highlighted. Since that little exponent is a 2, it's telling us that it must have 2 solutions. Let's pretend that that little number, that exponent, was a 10. That little 10 is telling us that it must have 10 solutions. Okay? Whatever that exponent is. Then it says imaginary solutions. What the heck are these? Well, when we graph them, we can't see them. They are imaginary. Okay? But we're going to still talk about them. We're going to figure them out. The next blank says if a quadratic has a highest exponent of 2. Okay? Or it has the highest exponent of 2, then there must always be 2 solutions. So a quadratic always has 2 solutions. Although sometimes we can't see them because those imaginary solutions we can't get, real solutions will appear as x-intercepts. And if this is not making any sense to you, let's look at our 3 possibilities down below. We have possibility 1, possibility 2, and possibility 3. Let's focus in on possibility number 1. Possibility number 1, I see that I have 2 spots here that my parabola crosses the x-axis. That means that this graph has 2 real solutions. And remember, a parabola can only have 2 solutions. It has 2 solutions at the most. So if I'm going to go ahead and write one more thing down, let's go ahead and write down that it has 0 imaginary solutions. And the reason I know that is because when I total these up, this total has to equal 2. Okay, so I'm going to write 2 as the total. Okay, so I saw from my graph that it has 2 real solutions. It crosses twice, which makes it have 0 imaginary. Okay, my other situation is situation 2 in the middle. This looks a little bit different, so I'm going to label this as my special case. Okay, this is my special case. Now, I need you to imagine a bouncy ball. Imagine you are throwing a bouncy ball down at the ground, and all of a sudden it hits the ground and it pops back up, right? It bounces back to you. So I'm going to label this point right here where we have that dot as a bounce. Okay, so I'm going to put this is a bounce. And what I mean by that is my graph goes down, it hits that x-axis, and all of a sudden it pops back up. It bounces back up. Okay, so sometimes you might hear us refer to it as a bounce point. Okay, and this is a special case because even though it only looks like there is one real solution, we actually have 2 real solutions. That's why it's kind of rare. And if we have 2 real solutions, we have 0 imaginary. And the reason I could figure that out, the reason I knew that is because when I go ahead and add them up going down, it already totals to 2. Okay, so this already has a 2, so that means that automatically is a 0. And again, this is a rare kind of special case. Our last one, possibility 3, this parabola is just kind of floating. It's floating up there. It's not touching the x-axis at all. That means that I'm going to write down 0 real solutions. It's kind of just hanging out. Well, that's not good because I know it has to have 2, but I see none. So that means when I think about adding this going down, I must have 2 imaginary solutions. And the reason I know that is because when I go ahead and add down, I have a total of 2. So I can't see any, but I know it has to equal 2, so my imaginary must be 2. Okay. Next page, we're going to do a little bit of forming the graph from the information provided. So example 2. Sketch the graph of the quadratic function with the given information. It gives you 3 pieces. Those 3 pieces are that the vertex is 2, -4, and it's increasing from 2 to positive infinity, decreasing from negative infinity to 2. Let's go ahead and label a few things. I'm going to plot my vertex. My vertex is over 2, down 4. Okay, and I'm going to label that with a V. That's my vertex. Okay, that's kind of like the middle of my graph. So I'm going to go ahead and dotted line it. That's where my middle of my parabola is going to happen. Now, from the vertex, the next piece of information says it is increasing from positive 2 to infinity. And if you want to write infinity on the right, negative infinity on the left, that might help you out. It is increasing from 2 to positive infinity, so it's going up to the right. Then the other piece says that it's decreasing from negative infinity to 2. So my other side, when I think about this, it's going down until it hits my vertex, and then it's increasing the other direction. So we just formed our parabola. Now a couple questions that we have to fill in. It says, how many real solutions does the graph have? Well, real solutions is where it crosses the x-axis. In this case, I have 2 real solutions. I went ahead and put big kind of blue dots there. So it says, how many imaginary solutions does your graph have? Remember, it totals to 2, so I already have 2 real, so I must have 0 imaginary. Problem B. Same information, but different numbers. My vertex is at 3, -6, so I'm going to go over 3 and down 6. I'm going to label that my vertex, and I'm going to do my dotted line here because that's kind of the center of my parabola. Then from here I have a little thinking to do. I'm going to label negative infinity and positive infinity to help me out, and I need to read the rest of it. My graph is increasing from negative infinity over here to positive 3. So my graph is actually going up from negative infinity to positive 3. And then it is decreasing from 3 to infinity. So there's my parabola. It's opening down. Okay. Now, answering the last questions here. It says, how many real solutions does the graph have? Well, does this parabola ever cross the x-axis? I hope you were thinking no, because it doesn't, and that means I have 0 real solutions. That means it implies that I have 2 real solutions. Remember, these numbers right here have to add up to 2. Okay, last example. Sketch the graph of the following function. Gives us those 3 pieces. My vertex this time is at -7, -2. So I'm going to label that with a V and put in a dotted line. That's kind of my middle of my graph. Okay. Now I need to read my information. I have negative infinity on the left, positive infinity on the right. I am increasing from negative infinity to from -7 to positive infinity. So my graph is increasing that direction, but it is decreasing from negative infinity to -7. So it looks kind of like that. How many real solutions does the graph have? Well, it's crossing the x-axis in 2 spots. I went ahead and put dots there. It's crossing in 2 spots. I have to total to 2, and I already used 2. So that means my imaginary solutions are 0. Make sure you go back, maybe pause the video, and make sure you understand increasing and decreasing. Increasing and decreasing sometimes really messes up students because you're only looking at the x values. Okay, so maybe go back and re-listen to that section.